welcome to the first of many webinars ColorLogic and CrossXColor will be holding. ColorLogic and CrossXColor are partner companies who sell high-end color management solutions. ColorLogic and their sales team serves the European market and rest of world. CrossXColor and their sales team are serving the American market. In this webinar of today, we are working with two of our tools, CoPrA and ColorAnt. We are optimizing bad measurement data with ColorAnt, including the evaluation of measurement data, before we are creating the profiles with CoPrA for CMYK and RGB printer profiles. We will look specifically into special features of CoPrA, being the perceptual rendering options, the black generation and black point options, viewing conditions and others. A very important part of my presentation is how to check and evaluate if an ICC profiles are in a good quality. I will show tools and methods to make this critical step fast and easy. We are going to convert images with the CoPrA image conversion feature, and we are using test images and evaluate those test images inside Photoshop. I will show and compare profiles with poor quality measurement data versus optimized data so that you understand the relevance of ColorAnt. So that's the first webinar we are going to do. We will hold a few other webinars because CoPrA is such a very mighty functionality. So it has printer profiling, it has device link profile, it has safe ink profiling, and it has editing functionalities. We can't cover this all in one seminar. So the big star, let's say, is the full package, CoPrA full package. We will cover the device link part, for example, in the next webinar, which will be on August 19th. There we will do a CMYK to CMYK tag reduction ink saving profiles using the device link functionality inside CoPrA. And then the next webinar in August 29th will cover to use the device link profiles we've just created for the PDF color management. We will set up typical workflows and use cases with our color server Zebra. And in future webinars, we will be covering more workflow configurations and case studies that we can use with our workhorse Zebra, our color server. For example, gradation corrections on the fly, device link creation on the fly with our Smart Link module inside Zebra. And a specific topic will be about spot color on multicolor workflows that will be covered with CoPrA and Zebra. Before we look into the software, I want to give you a short overview what is ColorAnt. So whenever you're working to create profiles, you're working with a lot of different test charts and measurement data. There are a lot of measurement instruments out there, a lot of tools out there that are able to save the measurement data, to record the measurement data and save them as a text file, a CXF file, whatever. And ColorAnt is basically able to open all those measurement data files. So you can simply open them and save them to other color file formats if you like. But the most important part is, of course, if you open them inside ColorAnt, you want to visualize the measurement data. You want to spot if there are some errors in there before you create the profile with this measurement data. So in ColorAnt, we have tools to visualize the measurement data into different ways so that you really can see if there are some things which are not good. And the even more important part, you can correct those measurement errors before you create the profile. So basically you correct the measurement data, you save those optimized measurement data, and with those optimized measurement data you are able to prepare better profiles. The advantages of ColorAnt is that everybody that measures color will experience issues with measurement data, no doubt. And the more you measure, the more patches you have there, the more papers and inks and print systems you have, the more issues you will have with measurement data. And ColorAnt, as a standalone software, corrects and optimizes this measurement data before you create the profile. So that's the important use case of the ColorAnt application. It works on Mac and Windows, and it can be used in front of every profiling tool. Not only in front of only CoPrA, it can be used as well in front of other profiling tools, from X-Rite, from other tools, from GMG, from CGS, whatever. So you can use it everywhere. Despite the many functionality that ColorAnt has, it has as well an automatic feature to make the correction quick and easy to use. Our CoPrA application, that's the next application we will show during this presentation. The name comes from Color Profiling Application, and it is a complete suite of tools and modules. We have a first-class ICC output profile generation option there that creates RGB, gray, CMYK, multicolor printer profiles. So that's one module. The other module is for the device link creation. You can create device links for RGB, CMYK, gray, multicolor. You can switch between different color spaces and have a lot of options in there. And we have an editing module which saves any type of color transformation into a device link. That means you can use the most mighty editing application, which is Photoshop, and do whatever kind of selective and global correction and save them as a device link profile to be used further on into your workflow, for example. We have a module for safe ink profile creation, a very important module for large format printers, for roll offset printers, for gravure, for newspaper printers, because obviously they want to stabilize on ink and want to save on ink costs by using safe ink profiles. Abstract profiles can as well be created with CoPrA, which is a very unique functionality too. Looking at the advantages of CoPrA, CoPrA is a first-class professional application designed for the high-end market. We are not talking about the little guy here that has a little printer in his corner. We are talking about the real professional large format printers, the real professional web offset graver printers that want to use the highest quality they can get. The most important tools that we have are about device link profiling, which we don't cover at this presentation here, but we'll cover at the next webinar. And we offer maximum control for the device link profile creation. It has as well an easy-to-use, high-quality printer profiling tool. We will look into that during this presentation. And with that, CoPrA is the best profiling solution for printing companies, prepress managers, and operators. CoPrA includes as well all profiling features for packaging and HiFi printing. So for CMYK plus additional inks, it can be used. And it is a suite of products. It includes the ColorAnt. If you buy, for example, a CMYK printer profiling module, you get the ColorAnt for free with CoPrA. And we have as well the DocBees Profile Manager, which is there to organize your profiles, which can be used to create a report that evaluates your profile. A very handy tool. We'll look into that too. We are now just getting right into the application. So we are starting with CoPrA. As I've shown in my presentation, you can see here that CoPrA has a lot of different modules: the printer profiling module, the device linking, the device link editing, the safe ink. We are looking specifically into the printer profiling part, and I would like to show you how you would start if you would like to test yourself the applications that we have. You would get in contact with our sales team. They would provide you a link to the software and a demo license, and I show you how to work with a demo license. When you start the application, it is not licensed and you need to register first. That's done with the help register dialog. And here you simply load that demo license that you've received from your dealer. So I load this demo license here, which is valid till end of August, which is then shown directly into the software, and then you are free to test everything within the software application. So you can always go back to the home screen where you can start to use each of the modules. When we start with printer profiling, a very important part of printer profiling is working with measurement data and with test charts. And I don't want to spend too much time on measuring, but I will show you something how we are working with measurement data. The first thing is, if you have already some measurement data created with your device and save them to disk, you can simply drag and drop measurement data inside CoPrA, and then it will automatically detect the CMYK and the spectral data, for example. And depending on which kind of measurement data, for example, for an RGB device, you can simply drag and drop this in here and it will automatically detect the measurement data. However, if you want to work with our test charts, we have here under Help, Open Test Charts folder. We have different folders for CMYK, for example. And here you see we supply a test chart. Let's do it this way. We supply a test chart, which is a typical CMYK test chart, IT8 7.4, in a layout that you can measure with with instruments like an I1 or a Konica Minolta instrument or a Barbieri SpectroPad or LFP. So there are multiple ways to measure that test chart. If you have your own instrument that we do not directly support within our application, you have always the text file, the reference data, with which you can create your own TIFF file with the layout you want for your instrument. For example, if you are a user of an ICC, you can simply import that measurement file inside I1 Profiler, which is a free download. You can then import the measurement file here, the reference file here, create a test chart, measure with the I1 Profiler, with the ICC, save the data as either a CGETS text file or a CXF file, and simply import that inside CoPrA. That's quite easy. Or if you are using an I1, for example, or another instrument we are supporting directly, you could simply go to this button here, Measure, Start Measurement, and then we would start a tool that comes with CoPrA, which is a tool from the UGRA, which allows us to measure with some instruments. You would simply go to the wedge type here, to Others, select one of the ColorLogic strips, for example, the CMYK IT8 chart. You would select your instrument, so you have the choice of this kind of instruments. I don't have an instrument plugged in at this moment, but I would like to show you how we would measure with this virtual device. That's basically a simulation of a real measurement. For example, I would just do that with this little strip to make this fast. So you would connect your instrument, for example, an I1 or a Konica Minolta or Barbieri instrument, and then you would connect, and then you can measure directly to the application. You have different modes here for M1, M0, and so depending on the measurement instrument. And once your measurements is done, you simply say transmit, and the measurement data is transmit back to CoPrA so that you can work within CoPrA with measurement data. Obviously, we don't want to create a profile from just this small media wedge, but just to give you an idea how you can work with in our tools. But as I've mentioned, if you have your own tools, no problem with that. You can simply get measurement data inside of CoPrA by simply drag and drop those measurement data inside. So, but I don't want to start with CoPrA at this point. That was just a little excerpt about measurement data, getting measurement data. But we want to work with the measurement data, and therefore we are starting with ColorAnt. And ColorAnt is a tool to work with measurement data, to optimize the measurement data. So you can do the same thing. You simply drag and drop your measurement data in here. And you then select the measurement data. You can either double click or click on the view button to get an overview of your measurement file. So this is obviously a random layout where it's really hard to spot if there are some problems with the measurement data. Therefore, we have some other tools, for example, a three-dimensional view of the measurement file. So you can have a three-dimensional view here. You can make the dots a little smaller or bigger if you want. You can zoom in a little bit so that you have some ideas if there are some unsmoothnesses, like here, for example. This one looks a little bit unsmooth. So there are possibilities to better spot if there are some issues in the measurement file. So that's just one thing. Another thing is the TVI look. So you can have a look of how the curves are behaving. You're seeing, for example, in the magenta that this is a little bit ugly here. In the light areas, it looks a little bit bumpy, and it's not very smooth. Yeah? So you can see this here right away. So there are some issues either with the printer or the measurement data or both. The spiderweb is a very good view as well on the measurement file. So it shows you as well that, for example, this blue axis or the cyan axis or the green axis here, there are some really odd behaving things in here that you really want to optimize. And the other thing is in the curves itself, you can see how, for example, the black curve, you have different curves here, you can see all the curves. In the black curves, the black curve behaves. And you see something here, for example, for the 40% black patch, there are two of those patches inside the measurement data. And that's a very important thing to understand, because mostly in test charts there are multiple patches in different locations to check, for example, how evenly the printer is printing. However, if in this case you have the same patch with two different LAB values, which of the two values should the profiling use? And we call this redundant patches, and obviously we don't want to use either this or this, we want to use the average of those two patches. And therefore we have a tool here which is called the Redundancy Correction. You simply go there, you choose the automatic mode. We have different mathematic models here. The automatic will automatically determine which is the best to be used. So I would recommend to just use the automatic one. You click on OK, and the view is directly updated. And you'll see, I will go back here. We'll have always the history in here, so you can go back to the former values, and you'll see the redundant patches. There are multiples in here. You see those, you see those, you see those. They are now all corrected and averaged. So you have already a better data set. Let's have a look into, for example, the Magenta Curve. Here again, looking before and after, and we still see this quite odd behavior here. And we want to optimize that further. This can be done then with the next step, which is the correction step, where we want to correct what we call bad measurements. So we do that, and let's look at the first thing we've done. We started with, so we had this odd behavior here, and after the correction we have a much smoother, much better behaved curve. Now, we will see as well in the spider web that we're starting from here with all this odd behaving colors here, and after the correction we see, okay, that's much better now. Still, there are some unsmooth behaviors, but this is a stronger correction. We might want to smooth the measurement file further, because the data is quite acceptable. I would just take the data as it is after the correction, but however, I would like to show you what smoothing would do. If you go to the smoothing, you have some option here for a very strong smoothing, or a very weak smoothing, or a middle smoothing. You can even protect the highlight areas. This is very important for our Flexo customers that don't want to smooth out the highlight bumps that they have in Flexo. So they can say, okay, I don't want to smooth anything until 8%, for example. Now, in this example, it's from a LFP printing process, so we don't have the Flexo behavior here, and we want to do the smoothing for the entire code space. So if I do that, we will directly see how this reacts in the spider web. Now it's looking very nice, very smooth. We have fine, clear lines here for all our CMYK and RGB colors in there. Again, if I'm going back to what we had at the beginning, after the correction, which is already good, and after smoothing, you have a much finer granulation here in this data, which gives you a better result at the end. If you want to know how much we have changed the data, we can go here. I will switch out the view to the color comparison. Here you select the original data set, and here you select the one after all the corrections you've done. So I'm selecting this one at this point. And if you move with the mouse either here to the side or to the button, you will see on top the average over all patches, 0.4 delta E, and a peak of 2, which means despite all those nice optimization we have done, it is only a small change. It is only a small change, which means we are very close to the original characteristic of the printer. We are not changing the characteristic of the printer. We want to characterize the printer as it is, but we want to smooth out, we want to correct those little errors that are still in there. And we have done that in a very good way. As we've seen, we have only a very small change in the maximum delta E and a very good average on everything. If we want to compare to just the correction, I can simply select just the corrected version here, and we can see, okay, that's even less correction to the original data. So we have just an average of 0.2 around and a peak of below 2. Yeah? So that's not much. If we want to have a look on where those patches are, you can simply use the slider here to move them. And for example, if you go here to from 2 delta E on to 2 delta E 2000 on, it will only highlight those patches that are now having higher than 2 delta E, and it's basically this green patch only. So this is the highest delta E that we have here. On the graph window, we even see a better distribution of how the differences between those two characterization data is compared, and we have a statistics window as well. So that's quite a very helpful functionality to compare measurement data, and you can simply click on each of these patches and you'll see on the one hand the LIB values from this patch, from this test chart, and here on this below part you'll see the measurement data from this part. So you have a good view here how those colors compare. So, and if we want to work with this measurement data, you simply go there and you can simply click on Save. You can save the measurement file to a different kind of format. We want to use the text file here, but you can save it as a color exchange format if you like. We'll save it as a text file here. We'll save it as a to our desktop. And then we have our measurement file, which we could then use inside CoPrA. Another file I would like to show you is from a really bad measurement data that I have, which is coming from a digital printer. And we basically have the similar thing. We want to look a little bit on the measurement data, and we just double click here and we see, for example, the spider web, which is very, very odd behaving. We see the three-dimensional view, which shows us, well, there are really some issues, some problems in the data. Or if you look into the curves, there is a lot of noise in there, a lot of problems in there. However, still it is a random chart, and it's really hard to spot on a random chart which are the issues that I'm having. Therefore, I would like to start a little bit different with the rescaling tool. I go to the rescale and I can reformat the layout to something which is more visual, like for example an IT874 or an ECI 2002 layout. If I'm selecting that and I click on Start, you'll have a much better view on how the colors are distributed, and you're seeing all the artifacts already in a much better way. And we are still on the remission data, meaning the spectral data. We don't change the spectral data. We just format the data and we keep the data as they are. That means we have a good view on the unsmoothness here. We see some artifacts in here. We even see some artifacts here in the gray. We see it's getting darker, which is okay, but then it's getting lighter again, darker, lighter again. So we see all this kind of artifacts, which we obviously can see as well in the TVI curve. If you look here into the black curve, that's exactly what we've seen. It gets darker, then it gets lighter, it gets darker again, and so on. So it's not really nice, and the magenta is even worse than the yellow too. So we want to do some optimization here. You could do this correction as I've done in the first example by using all those tools one after the other, or you could simply use the automatic feature, which does the correction that are needed automatically for you. So you just simply click here, say Start, and it would do this correction for you automatically in the right order. And doing this, after the correction, you see you have a much better behaved data set, which gives you much better profiles at the end. So if I'm now looking into the TVI curve, so that's much, much smoother compared to where we started from, which was like this. Yeah, so our measurement data is much better. Obviously, this printer has some severe problems. The spider web is still an ugly one, and the data still is ugly. But sometimes you simply have to take the measurement data as it is, and sometimes it don't get even better because the device is that bad, and you have to print with it anyway. So you want to get good measurement data to work with. Here in the history, you can always get back to each of the steps and go there and go from each of the steps. So if, for example, if you don't want to have the smoothing, you simply click on the correct one, and then we are going one step back and we have just the corrected data. In this example, obviously we want to have the smooth data as well. So I click on smooth, save to disk again, and I save it here to my desktop again so that I can create a profile. So that's about ColorAnt in this demonstration, at least at this point. And I will switch now to CoPrA to create the profile from this example with this bad behaved measurement data. So what I would like to do is to create two profiles. One profile with the original, not optimized, really bad behaved data, and the one with the optimized data, so that we have a good comparison then when we apply those profiles later on a test image to see what's happening and how it improves the profile quality. So I'm selecting a setting which I've created upfront. We will look into how to create settings and what that means later on. Select the setting here, you're going to next, and you're giving the profile a name. So this is my digital printer. You select the format that you want, either ICC version 4 or 2. Select the 2. You select the size of the profile. Large is a good compromise. And then you create the profile. You will get an information because with a demo license, we will create a demo profile, which is basically a profile which is encrypted. So you can't use that profile in, for example, Photoshop, but only within our applications. So we create the profile, and you see there's a new dialog coming up, which is this batch profiler dialog, which allows you that during the calculation you don't have to wait. You can simply go back and create another profile with different settings. And that's what we want to do. We want to take our optimized measurement data. I simply select this here. I select the same setting, so we want to create another profile with the optimized data, and I create another profile. Again, a demo profile will be created, and you'll see during the first one has been finished, the second one is starting, and you could now create another profile with different kind of settings. So I've created those profiles already, so we leave CoPrA calculating the profile, but we can use them already. So we are going to the image conversion. And here you have the choice to work with this demo profiles. You can't use the demo profiles somewhere else. You can use them inside our CoPrA application, but you can do all the color conversion within this image conversion feature. So you select your source file that you want to convert. I've selected here one of our edit targets that we supply with CoPrA. These are very good test images to evaluate the profile quality. You'll find those images here under Open Edit Targets folder. And here we have one for CMYK, for gray, for LIB, or RGB, and that's the RGB one, which I've selected here. But in my example, I want to use another one. This is this test image. You simply drag and drop that here. So this image has some well-known test images like the Roman 16. It has some smooth shades here, some high saturated colors. So it gives a good overview about the quality of the profile. You select the source profile. It has an embedded profile. It shows us here. So I select the source profile ECI RGB, and I then select my digital printer profile I've just created. So we are starting with the original one. I'm selecting here. You select the rendering intent we want to convert with, so either perceptual or black point compensation. We want to use the perceptual one. We embed the target profile in here, and we save the converted file to disk. You have the choice of either TIFF, JPEG, or PSD. I'll take the TIFF here, and this is the original bad data conversion and profile I'm using here. So I save that to disk. And obviously we want to compare it to the optimized data after the ColorAnt optimization of the measurement data. And I save this one to disk 2, and I call it optimized. So I have two TIFF files now that have been converted with the image conversion tool, and I can simply select them and open them inside Photoshop for further inspection. So if I do this, this is my original bad data, and if I zoom a little bit in, you'll see all this unsmooth behaved conversions here. That's really bad behaved. You can see it as well in the image here. This blue is really spiky with a lot of artifacts in here. You can see some artifacts here in this area where it's getting lighter and very dark in this area, so that is looking really bad. You have some detail losses in the hair of this guy here, so it's really not a very nice conversion. However, if I take the optimized profile, the profile with the optimized data, you'll see it's much smoother here. You don't have that artifacts in the blue anymore. You have a good dark background, so there's not those artifacts anymore, and there is detail in the hair of this guy. So I'm switching that back to the bad data. You'll see even some artifacts here in the green can be spotted, and after the correction it is much smoother. So this shows the importance of ColorAnt to optimize the measurement data before you create a profile. Now we want to look a little bit more into the details of how to create good printer profiles. And I will start with the example with the better data that we had. And we want to, this time, look into the details of how we create profiles. So we have two options here. We just go there, and we have General tab and the Black Generation tab. I'm starting with the Black Generation. And here you have the option to select a setting, as in the previous screen, and which, for example, if you are on an offset printing process, you select one of those presets, and depending on the presets, you'll see that all the settings are changing and you get another view of the separation. Now, for example, here, that's the digital printer demo I've used, or if in this example, this is an inkjet kind of device, so I'm selecting this setting, for example, as a starting point. And here you have the typical suspects, let's say. You have an UCR, you have a GCR option. If you are working with a GCR, you can define the amount of the GCR from a very weak one to a very strong one. So we have options there. You can define how the black start shall work. So for example, for an inkjet, you typically want to start quite late with the black, so that you don't have the peppering effect in the light areas. You have a black width slider that you can move. And a very important part as well of a profile is the black point. And the black point determines the contrast, basically, and the details you will get. Therefore, the black point is so important. We have some options here to how to calculate the black point, and the automatic feature is a very helpful one, because it gives you an indication from the measurement data that you have how you should set the measurement data in the auto mode, but you can start from scratch by simply dragging it to the maximum and then simply clicking on this little gear here, which calculates the recommended black point for you. So if I click here, it gives you that value. And why is that recommended? We can have a look here, because we give the LIB values for the black point that we are going to calculate. This is the L star, and this is A and B. We want to create an as neutral as possible black point, so it's 0, 0, so that's fine. And we see we have an 18 L star, which is a dark black point, but not as dark as it could be. However, if somebody says, okay, I want to check, perhaps I can use something like 300%, you can simply go there and select 300% total area coverage. Now, for example, we go there, and if you now click the gear button here, you'll see what happens. You get a neutral black point, yes, but your L star is getting higher, which means you're getting lighter in the black point, which means you're losing contrast. So it's not a good idea to go down to 300 or even more if you go down this way, very hard way. So you lose contrast, and that is not a good thing to do. So you rather want to stay higher in the total area coverage. For example, if I go there, we'll see what happens. We have a 19.5, which loses already some details. If you go there, we can see, okay, 385 is the best compromise, it seems. So we take this as our starting point. Obviously, this is possible with an inkjet system. After linearization, you probably want to start with a very high total area coverage. On an offset kind of process, you never want to use something like 385 or on uncoated paper and such. And therefore, we have those nice presets here. For example, if you're in an offset uncoated world, you want to use something like 280, for example, rather than 380. Going back to my inkjet, you'll see that all those settings which are here, all the settings that I'm using, will be modified, like this inkjet edited one, has this edited mentioned at the ending, so that I can go back to my last setting, which I've selected before I switched to the other setting, so I don't lose any settings that I've done. And I could rename that to my personal inkjet test, for example. And in the future setting, in the future use of CoPrA, I always have that setting available so that I can apply it to incoming data that I want to use with the same setting. And that's the way how I've created my digital printer demo example as well, that I've created this way. So I've renamed the setting to my purpose. I want to use that in inkjet test, and I'm creating that profile now. So that's my inkjet. Inkjet profile with a tag of 385, and this time I want to use the profile report functionality, because when it creates the profile, again a demo profile will be created, I'll have the nice functionality that it gives me as well some information about how good this profile is. Because typically if I'm creating a profile, well, what would I do to evaluate how the profile is? I would take a test image, a good test image with a lot of details in there, with a lot of gray balance parts in there, with some difficult images, with some smooth images. And I want to look at separations. I want to see how smooth the gray balance is, how the separation is. I want to see if my total area coverage is reached, or if I have some artifacts in there. And all this kind of testing can be done manually, no doubt about that, but it takes a lot of time. And you will see here that after the creation of the profile, we'll get an automatically generated profile report, which will open up in Acrobat later on, which gives you all this kind of information. For example, we can see the precision of the profile, how good the profile is able to reproduce his own measurement data. This is shown here in this line, where we see the average and the maximum error that we have in that profile. So overall, we have an 0.1 delta E average, which is very, very exact, and only a peak of 2.5, which is very, very good. We can see how the total area coverage is. This is exactly the total area coverage we've entered inside CoPrA. So we can see that this is reached within the profile. We see the information about the black point, the white point, and further on we have a look on the gamut. So a profile has multiple gamuts. For example, it represents the measurement data, the absolute colorimetric gamut, that's the red one. When you use the relative colorimetric rendering intent, you have a slightly bigger color space, which is shown here in the green one. And with the perceptual perceptual rendering intent, you get the gamut mapping, and therefore you get a bigger color space at the end. You have the spider web, which we show here as well. And we have some gamut volume information. For example, we want to know, is this printer able to reproduce, for example, an sRGB or Adobe RGB or ISO-coated. And for example, if I want to prove ISO-coated on this inkjet printer, I see, well, ISO-coated is a little bit bigger, so it's not a good idea to simulate ISO-coated because that ICC profile is a little smaller. So I can't use it for proofing. And obviously, sRGB and Adobe RGB profiles have a much bigger gamut, so you can't reproduce them entirely. But that's a normal thing. You can't reproduce Adobe RGB exactly on any printer in this world. The next thing we want to know is how smooth and how is the gray balance set up. We can see it when we do the perceptual rendering or relative plus black point rendering. So we'll see that the gray balance is okay, that our starting black is quite late as we set up in the profile. We have some other information here about relative colorimetric and absolute colorimetric, how the gray balance reacts. The next thing we want to see is how good is the profile when it should render a very smooth Adobe RGB blend of colors into CMYK. And we see that's the original one, that's the CMYK conversion with the perceptual rendering intent. We see that's very, very smooth, no artifacts can be spotted, so that's quite nice. and we see how the conversion is done with colorimetric plus black point compensation, so that's very nice too. And typically I want to see how is a CMY without black. So I would go to Photoshop and go to the channels and switch off the K, and that's done here for me automatically. So I see the CMY perceptual conversion without the black, so I can see if there are some problems in the CMY, but that's all smooth, so very nice. And I want to look into each of the channels, looking at the black channel, the cyan channel. They're all looking without having some artifacts, magenta, yellow, that's all fine. So I have all this information right into that report without me having to do anything. So that's really helpful to get a fast overview about the quality of the profile. That's our test image, our image which we here in this report have assigned Adobe RGB to. We can see how it should look in the original, and this is the converted one using the perceptual rendering. Obviously we can't reproduce those high saturated colors, but still we have very high saturated yellows and reds and blues. The gray balance is very nice and there are no detail losses, so that's all fine. This is done with the perceptual rendering or with the colorimetric plus black point compensation. We can see that for this image, using the perceptual rendering intent will increase the highlights a little bit over the black point compensation, which gives a better rendering and details in the shadow and mid-tones. So that's all fine. We get some information as well about, for example, edge values. How is the pure red, green and blue in RGB is rendered to CMYK. I get this information right here, so I don't have to put a patch inside Photoshop where I have to go with a pipette in there and to see how the CMYK values are. I get this information right here into that report. I can see how the rendering is done using the colorimetric plus black point compensation or with the saturation rendering intent. We have a very nice saturation rendering intent. So whenever you like more saturation than that is delivered with the perceptual rendering intent, just try the saturation rendering intent in the profile. It would give you more saturation. Then we have some, let's say, geeky colors here where we compare the hues, the colors of some example hues. These are the original ones and these are the converted ones, so that we can see how the gamut mapping works. Well, that's is a little bit more for the geeks, so I will just go over that. In the linearity part, we show the colorimetric linearity of that profile. With this, if this is a pure nice line, we can see if, for example, an inkjet has used a good linearization before the profile was created. Obviously, it was not that good here in this part because we see not straight curves here. We see the dot gain calculated from the XYZ data and from the spectral data if we use spectral data. You can see those bumpy curves here because obviously I haven't used the corrected data from ColorAnt. So I will do a next step with CoPrA and going back into the settings. So we've created the profile with the black generation, so that's fine. And now we want to look into the general tab. So which kind of options do we have in here? And that's exactly the thing which I have forgotten basically in the first step when I created the profile, to switch on the measurement correction feature. That's basically the same thing like the ColorAnt automatic button. You remember when I click the automatic button, the redundancy correction, the correction and the smoothing is applied. For those people that want to get right to the result and don't want to look into the details, they can simply load the measurement data inside CoPrA, click the measurement correction button, and it will do the same correction as the ColorAnt would do. For those people that want to know more and want to have more detailed information or want to do the smoothing manually in using the slider, they can go in there and make their own corrections. For example, for the brightener correction, this is just a checkbox inside ColorAnt. You have here the option to do a correction with a slider setting. So you have a very strong correction or a very weak correction. And just to give you that information, CoPrA would use a 50% correction basically when you compare it to ColorAnt. So for those that want to get faster to the result, they can use this, just the measurement processing part inside CoPrA. So that is one thing we could use here. We have the viewing condition, which is basically ICC profile always creates profiles according to the 50 lighting condition. However, if you have other lighting conditions, you can target the profile to work better under this lighting condition. A very nice feature and a unique feature basically is that if you have an instrument like an i1 Professional or Konica Minolta where you can measure the ambient light in a spectral way, you can load this spectral information inside CoPrA to create a profile that is then targeted perfectly for this lighting condition. That means you would select the emission option here, and then you would select the light information from the viewing condition, for example here from an LED light spectrum. You can simply open that. You get a correlated color temperature, which is very close to D50 as it looks like, but the curve is quite different. So it gives a different result if you would use D50 versus the real lighting condition under which you're looking at this print after on. So this gives a much better result for this lighting condition if you use the emission viewing condition option. But typically, if you have a normal workflow, you select the default, which is D50. Another thing which is very important is the perceptual rendering. We don't believe that there's only one perceptual which always fits in every situation. We believe we have to have different options there. And you can say inside the CoPrA application which of those three options you want to choose when you apply the perceptual rendering option. For example, I lately had a client that works with an old RIP system that does not have any black point compensation. But he wanted to use black point compensation, and we have a good solution for him because he could simply select the black point compensation here as the perceptual rendering intent and then use in his RIP the perceptual rendering, and in fact it would use a black point compensation. So we would put the black point compensation into our perceptual rendering intent, but in a much better quality than what you would get inside Photoshop, because typically inside Photoshop you get a good gray balance, no doubt about that. The problem is with high saturated RGB colors, for example. They simply get clipped, so you have detail losses in those colors. Using our black point compensation, we'll have gamut mapping and therefore better details in those regions. I will show you that in an example file. Other options here, the standard compression, that's our default setting. If you just print on one device and want to get the best print out of that device, you would select the standard compression. And the absolute compression, have a look here into this graph. You will see that this will change, this view will change. The gray balance from our absolute measurement data, which is shown here as this blue color, compared to the perceptual rendering intent. Remember that using the perceptual rendering intent, the gamut will be higher, will be bigger. But you typically have as well, with black point compensation or standard, you will have as well that your original gray balance, which is here in this example a little bit more targeted to the yellow, will switch to the neutral. So it will be neutralized, so disregarding the paper color basically. If you want to take the paper color into account, you can use the absolute compression, which means that we will stay close to the original paper color. That's a very, very important option for clients that you would work with, for example, a large print buyer that wants to have the same color appearance on different kind of printing processes with different kind of papers. And he wants to have the same color appearance of the gray balance. Then you should use the absolute compression, because on the yellowish paper and on a bluish paper, typically the gray balance will be different. On a yellowish paper, you have a more yellowish paper tint, and therefore the gray balance will be yellowish. On a bluish paper, the gray balance will be bluish. And if you put those prints side by side, it would look bad. But if you use the absolute compression on both prints, you will have the same color appearance for the gray balance. It's a very, very nice functionality, very important functionality. And I would like to show that inside Photoshop on an example that I've done. Here, that's the example from Adobe RGB to swap. What I've used is this one, this example image that we supply with our software. So that's my original example image that we deliver within CoPrA. So I've assigned the Adobe RGB profile to that image, as you can see here. So that's my original one, and that's my converted image. This is now using relative plus black point only at this point. If you switch between those two, so the original one, which is here, you can see those high saturated colors. You can see the red, green, and blues, magenta, cyan, and yellows, really pure colors, which you never are able to print on your print process. So you'll have this kind of degradation, obviously. But you can see the gray balance is very fine. The skin tones are very, very close, if not the same to the original, so that's all fine. And you'll see that you have high saturated colors, but as well some issues just using the relative plus black point compensation option if you do the conversion inside Photoshop. If you use perceptual rendering intent using the black point compensation option within CoPrA, you get this result. So if you see here, so I've put a layered file here with different kind of conversions so that I can switch between all the layers. If I switch back, that's the relative colorimetric, and this is the black point compensation. So basically what we can see, we have a better definition, more details here in this red area. We have more details here into the blue areas, which is harder to spot, but we have a better viewing here, better details here in this area. So we can see that the black point compensation gives the same rendering to the gray balance and to the skin tones, but we have more details in some higher saturated colors. Using the standard compression, we can see only a very slight difference here in this example, because swap is quite a bigger color space, so we don't do this very strong increase of lightness. If swap would be a smaller color space, we would do even more increase in lightness in the darker areas. And the other one I would like to show you is the absolute compression. And just have a look here into this color here. That's basically this anchor point here, which I've set for this neutral gray. If we look into the original one, that's this neutral gray, which has an LAB value, which you can see on the right side of 7100 AB 00, which means it is completely neutral. Now, if you look here, using the black point compensation or relative plus black point, you'll see it has this yellow touch. And that's because the paper of swap 5, coated 5, has this yellow paper tint. Therefore, you have a yellowish gray balance at the end. So basically, this is a more yellowish gray balance, which can be seen on this LAB value. But if you use the absolute compression, have a look here, you have exactly this AB0. And that's what I've mentioned at the beginning. On the yellowish paper, using the absolute compression, you have a neutral gray balance. And on a bluish paper, you would have as well a neutral gray balance. And if you put those prints to each other, they would look the same. And the final thing I would like to show to you is, which is already an outlook to our next session about device link profiles. So that's the conversion that we get with a normal ICC conversion. And now we have a look into the conversion that we can get with a device link. So have a look into what you see here. So we have pure cyan, we have pure yellows, pure magentas, we have higher saturated reds, greens, and blues compared to just the normal ICC conversion. And that's one of the beauties of the device links, because you can have you can target how the conversion should be to get higher saturated colors out there. So you get a much better yellow here with much cleaner color, and you get better reds and better greens here. So that's really a nice improvement of the image I can get with a device link. And how to create that device link, I'm happy to show you in the next webinars from us. The next one will be 19th of August. I would be happy if you would join us for this webinar. I thank you very much for joining us at this first seminar for the ColorLogic CoPrA color solutions we are offering, and I thank you for your attention.